What is effective nuclear charge? I'm going to teach you easy way to understand effective nuclear charge. At the end, I will show you the trends of effective nuclear charge in group and in period of periodic table. Consider atom of magnesium. An atom contains a central nucleus with positively charged protons. The nucleus is surrounded by negatively charged electrons located on energy levels. The similar charges repel and opposite charges attract each other. Positive charge of protons attracts with negative charge of electrons. The inner electrons reduce attraction between nucleus and the outermost electrons. This process of reduction attraction between nucleus and the outermost electrons is called shielding effect. Listen carefully. The inner electrons reduce attraction between nucleus and the outermost electrons. This process of reduction attraction between nucleus and the outermost electrons is called shielding effect. The positive charge remains after shielding effect. That one reach on outermost electrons is called effective nuclear charge. Definition of effective nuclear charge. The effective nuclear charge is the net positive charge which reach on outermost electrons. Listen carefully. The effective nuclear charge is the net positive charge which reach on outermost electrons. It can be approximated by the equation Zef equals Z negative S, where Z is the atomic number and S is the number of shielding electrons. Trends of effective nuclear charge down the group. Effective nuclear charge depends on two factors: shielding effect and atomic radius. Consider these elements from group 1, from lithium to potassium. Up to down in the same group, the number of energy levels increase and number of inner electrons also increase. As number of inner electrons increase, the shielding effect also increases. High shielding effect reduce attraction between nucleus and the outermost electrons. As shielding effect increases up to down, the effective nuclear charge decreases up to down. Effect of atomic radius on shielding effect. Consider these elements from group 1, from lithium to potassium. Up to down in the same group, the distance between nucleus and outermost energy level increases. According to Coulomb's law, when the distance between two charges increases, the force of attraction decrease squared. The distance between nucleus and outermost energy level increases up to down. This causes effective nuclear charge to decrease up to down. Trends of effective nuclear charge across the period. Consider these elements from period 3. Left to right in the same period, the strength of shielding effect remains constant because inner electrons also remain constant. Left to right in the same period, the number of protons increase. The protons are added to the nucleus as electrons are being added to the same energy level. Electrons are strongly attracted closer to the nucleus because of increase of positive charge in nucleus. Since the force of attraction between nucleus and electrons increases, the size of the atoms decreases. As a result, effective nuclear charge increase left to right. The summary. The effective nuclear charge is the net positive charge which reach on outermost electrons. Up to down in the same group, effective nuclear charge decreases. Left to right in the same period, effective nuclear charge increase. Thank you for watching. Subscribe for more videos.